In the next exam question, we have two stationary steel balls A and B, which are suspended next to each other by a massless inelastic string as shown in diagram 1. Ball A of mass 0.2 kg is displaced through a vertical distance of 0.2 meters. When ball A is released, it collides elastically head-on with ball B and ignore all effects of air friction. 4.1 then asks, what is meant by an elastic collision? So in other words, the total momentum before a collision will be equal to the total momentum after, as well as the kinetic energy before and after a collision. Immediately after the collision, ball A moves horizontally backwards to the left. Ball B acquires a kinetic energy of 0.12 joules and moves horizontally forward to the right. Before we look at the rest of the questions, we can evaluate the new information given. So before the collision, ball A has a kinetic energy, seeing that it will have a velocity. Ball B is stationary, therefore its velocity is 0, and therefore its kinetic energy would be 0. After the collision, ball A is said to move backwards to the left, so it will have a velocity to the left as well as a kinetic energy. Ball B has a velocity to the right and obtains a kinetic energy of 0.12 joule to the right. Question 4.2 then says, calculate the kinetic energy of ball A just before it collides with ball B using energy principles only for a total of 3 marks. So what 4.2 asks is to calculate the kinetic energy of A just before it hits B. So we want the kinetic energy over there. Seeing that there is no air friction in this problem, we can use the law of conservation of mechanical energy in order to calculate the energy of my system there. This means that all the mechanical energy at the top would be equal to the mechanical energy at the bottom. So remember that mechanical energy is the sum of the kinetic as well as the potential energy. Now, seeing as my pendulum is released from rest, the velocity at the top would be equal to 0, which means that the kinetic energy is 0. As my pendulum moves to its bottom position, it means that the height is 0, which also says that the potential energy at the bottom would be equal to 0. Therefore, we have the potential energy at the top equal to the kinetic energy at the bottom, which gives you an energy of 0.39 joule. 4.3 asks to calculate the speed of ball A immediately after the collision. So 4.3 asks us to calculate the speed of ball A as it moves backwards. What we have is the kinetic energy of ball A as well as the kinetic energy of ball B as it moves to the right. Now, since ball B was initially stationary, it means that all the energy that it has after the collision, it obtained from ball A. We can therefore go and use the law of conservation of mechanical energy by stating that all the kinetic energy before the collision needs to equal all the kinetic after the collision. And we can only apply this law if it is an elastic collision as stated in the text. Here I am taking direction to the right as positive. So the kinetic energy left over for ball A is 0.27 joule. We were asked, however, to calculate the speed of ball A. We can do that by using the following formula, giving us a velocity of 1.64 meters per second to the left. 4.4 asks us to calculate the magnitude of the impulse of ball A during the collision for a total of 5 marks. Now remember, impulse we can calculate by using one of the following formulas. Looking at this formula, we can see that we have the mass of A, the final velocity of A, which we just calculated after the collision, but the initial velocity, we only have the kinetic energy of A. So in order to calculate VA, we would have to apply our kinetic energy formula first, which gives me a velocity of 1.97. We can now calculate the impulse by using the mass, the final velocity of 1.64 to the left, as well as the initial velocity of 1.97 to the right. Because direction is important, I'm going to take right as positive, which means that this VA final needs to be a negative, which gives me an impulse of 0.72 Newton per second. Seeing that they asked the magnitude, it is not necessary to indicate direction, but because we had a negative answer, it means that the impulse would be to the left.